Uh, in today's session, we'll try to understand, what cloud computing is, what Azure is, and what all various services that Azure offers, right? So we'll quickly go through the various aspects of Azure as a cloud platform. So that is what we're going to cover today in this particular demo session. All right. Now, when you talk about Azure, right, we cannot directly go to Azure. First of all, we have to understand what led to the development of cloud computing, right? What made on-premise environment or private cloud, as you call it, what were the limitations there? What were the issues there, or what benefits did cloud computing or these cloud service providers, as you call them, CSPs, what benefits they offered, for organizations and entities to move to cloud, public cloud. All right. So cloud computing in general is a model, right, that allows you to create resources on the cloud. When I say on the cloud, what I'm trying to say is that you will not be creating these resources in your own environment. All right. These resources will be created somewhere else in the data center that will be managed by the CSP. All right. CSP stands for Cloud Service Provider. You have Azure, you have AWS, you have GCP. These are all different CSPs that exist. IBM, all right. Red Hat also offers cloud solutions too. So these are all different cloud platforms. Now, what type of resources are we talking about, right? And how do we access these resources? So let's take a very small example that you want to train a machine learning model, right? And the data that you have, right? Let's say this is 2 terabytes in size, and the compute that you need to train your model. Let's say you need 8 cores of CPU and 64 GB RAM, right? And you do that with a laptop in hand, which is an i5 laptop, let's say, for example, right? Which has, let's say 4 cores and 16 GB RAM. Yes. And 512 GB of SSD storage. That means I cannot do it on this machine, right? Clearly, I cannot do it on this machine. So I need another machine to do this task, right? Now I have two options. One, I can go ahead and create a virtual machine on the cloud, right? Where, the cloud is basically the data center, right? You can think of it like a building. And within this building, the cloud service provider will have a lot of servers which will offer the compute. There will be a lot of storage there. There will be networking installations there. There will be cooling system there. So everything that you can think of in a proper on-premise data center. When I say on-premise data center, I am referring to data centers that organizations built within their own campuses, right? So all these major organizations, if you see in India, right, Infosys, TCS, Wipro, they would have created their own data centers, right? And they would be utilizing those data centers for their compute requirements or storage requirements, right, to host their applications, right? Servers where their applications would be hosted. Now, this servers, right? If I want to create this, right, on the cloud, as I said, I can create it on a virtual machine, which will be hosted on the cloud environment, right? So then environment which is not on premise is the cloud environment that you access over the internet, right? If Azure has built a data center or AWS has built a data center, they will never let you enter the data center. All right. They'll not let you go to the servers, the racks, wherever they have stored it. They'll never let you do that. All right. So this is something which you can only access over the internet, right? So you just need a machine and you can configure your virtual machines, and within 5 minutes, right? Within 5 minutes, you'll have this resource ready. 8 core CPU, 64 GB RAM, 2 terabytes of hard disk. You can have 4 terabytes of hard disk there, right? And the best part is there is no extra payment that you have to do, right? When I say extra payment, obviously there will be some payment that you'll have to do, but that will be nominal per hour rent. All right. So I'll tell you, for a virtual machine that has, let's say 4 cores of CPU and 16 GB RAM, the cost of running this virtual machine per hour is almost 16 rupees. So for 1 hour, I'll only spend 16 rupees. All right. So that means if I want to, run it for an entire day, I'll incur a cost of around almost some 400 odd rupees, right, per day. If I want to train this model for 5 days, that is almost, very nominal fee. Compare it to a situation where you have to go ahead and buy these resources, right? Cannot do. So these resources can put anything. I gave you an example of a virtual machine there where you want to create a machine very similar to your laptop to train your AI model. But there are several resources that you can create, right? For example, the Databricks resources that we are going to work with. It's an analytics, data engineering resource, right? Azure Data Lake. If I want to store data, I can create this data lake, right? So you would have seen on Google, you get this, disk storage space available online, right, over the internet, right? Google will not give you the physical storage device. They'll not give it to you. They'll say that we'll let you create a space, whether 100 GB, 200 GB, 1 TB, 5 TB, 10 TB, whatever space you want. We'll give it to you, but you can only access it online over the internet, right? Networking resources. If you've created any resource and you create it on the cloud, right, then Azure will not have created that data center just right next to your house. Those data centers would be far, far away from where you are situated in some situation, right? So when I create a virtual machine, I generally select a region. When I say a region, that is where the data centers are, situated. So when I create a virtual machine, I create it in the East US region. So that is situated somewhere in United States, right? Now, for me to connect to that resource sitting in United States, that resource should be a part of a network. Yes or no? If that resource is not a part of network, then I cannot talk to it, right? You need network in order to talk to each other, right? So therefore, those networking resources will also be created on the cloud. You have several other networking resources like a firewall, a VPN gateway, right? These are all various, networking solutions that you create. Then you can create compute based resources also. Let's say I want to host a web application, right? So instead of hosting it on a server within my data center, I can go ahead and host that web application on the cloud, and the cloud will give me much more benefits, right? And a lot of features also to host that application on the cloud. A lot of features, right? That is why most of the organizations are today migrating to cloud. All right. And Azure is the fastest growing CSP in the world right now. All right. It's the fastest growing CSP. And various reasons for that, right? It's closely integrated with Microsoft, right? And it's created by Microsoft. Why not integrated? It's created by Microsoft. And Microsoft is something which is, closely integrated in our lives, right? Any organization you go to, they would be using Microsoft based products, right? So that is where Azure comes in handy. It connects to all those resources seamlessly. All right. So this is the most basic concept of cloud computing, that I want to create resources, but I will be creating them in a data center that will be owned and operated by a cloud service provider, right? And obviously, it's not something which I'll do out of my wish, right? This is not something which I wish for. It's going to give me benefits, right? That is why I'm going to go to the cloud and host my resources there. So when you talk about cloud computing, right, there are three different types of clouds that you talk about. The first is the private cloud. All right. Another name for private cloud is the on-premise system, all right, or on-premise environment. All right. On-premises also you would have seen somewhere. Now, these are data centers that organizations used to create back in the day. All right. A private cloud was created by the organization within their campus. All right. So if you go to a TCS campus, there would be a dedicated building that they would call a data center, right? Within that data center, they will have a lot of racks. On those racks, they would place all the servers. There would be storage devices, a lot of hardware, a lot of wires connecting all the servers together, creating a network. There would be a cooling system in place, because these servers, they tend to get very hot, right? When they're running, they tend to dissipate a lot of heat, right? So to manage those levels of heat, right, they have to have a very good cooling system in place. Now, these data centers were created by these organizations, in 80s 90s, around that time. And it had a lot of investment also, right? A lot of investment went into creating these data centers, right? uh, a lot of capital expenditure, right? We'll talk about capital expenditure and operational expenditure also. So organizations created these environments, these data centers within their campuses, and they were utilizing these, right? And the organization, since it is created this data center, it is operating this data center, therefore entire management, maintenance, everything related to the data center is the organization's headache now. Clear? They need to hire specialists, people who are going to take care of these data centers, who are going to work as the data center admins or administrators, who are going to manage their environment, right, their private cloud. And these data centers were only accessible to the associates or employees of that organization. All right, it's not accessible to users who are from outside the organization. Sometimes it will not be able you will not be able to access it over the internet also, right? So how many of you face that? To connect to your company's backbone network, you would have been asked to connect through a VPN. How many of you faced that in the past? Right, if you're sitting at home or you're in a remote location and you want to connect to this private cloud that we also call as the backbone network of your organization, right, then you would have been asked to connect through a VPN, right? They will never give direct access over the internet. All right. And only the employees of these organizations will have access to these data centers. So this was called as a private cloud. Then something changed. All right. Around 2010, something changed. What changed? Public cloud started becoming popular. All right. How did public cloud become popular? Let's see. Let's say, for example, and just a hypothetical situation, how it happened. Microsoft, let's say, came to Bangalore. All right, and I'm only giving you a hypothetical situation. They came to Bangalore and they wanted to create a data center. All right, they're very excited within their campus. They created a dedicated building, a huge data center they built. But what happened was that eventually they realized that they are not going to utilize this data center completely. They don't have that much work available or workloads available. All right. They realize that their usage of this data center will not exceed 10% of the total capacity. So, what about this remaining 90% of the data center? What should we do with this? And I'll give you a similar situation. Let's say you had a piece of land and you built a house with, let's say, 4 floors, right? So, ground, one, two, three. These are 4 different floors. Let's say you are a family of three and the ground floor is more than sufficient for you to stay. Now, obviously, when you built first, second, and third floor, there would be a lot of investment that went in, right? And the thing about investment is that everybody wants a return, right? If you had a huge family who would be occupying all these floors, that would have been a return, right? That it is catering to the needs of my family. But now you've put in a lot of money and you don't even have to use it. So what do you do to get your investment back? What do you do? Anyone?
Rent,
We
rent,
rent.
rent
You
it.
rent it out, correct? You rent it out. at least get some money back. And that is what, Microsoft also decided. We will rent this space out, right, where the users will pay an hourly rent, right? They will never get the ownership of this data center. They'll never have the ownership of the servers or the resources that they're using. They're strictly renting business. Correct? Something similar to your house. You'll never sell your house. It is only available for rent, right? So one organization came, it took a bit of a space here, right? Let's say this is the space that organization one took. Then another organization came, it took some space. Third organization came, it took some space. Fourth organization came, it took some space. Fifth organization came and they took a large space. So like this, Microsoft started renting out these data centers to, organizations from outside. All right. And what they realized was that it was a good earning opportunity. All right. It was a good earning opportunity to give out, this space within the data center out on rent. And that is what they started doing. Right. Now, what do you call a person who stays in your house on rent? What do you call them?
Tenant.
Tenant,
Tenant.
right? And that is a term that you would have seen in cloud computing also. All right. Let's say if this organization number 5 is Infosys. So this space is called as Infosys's tenant on Azure. All right. Our tenant, my organization tenant, right? Infosys is tenant, TCS is tenant, Wipro's tenant. All right. This space is called as a tenant. Now, this is how public cloud started becoming popular. And these organizations were not coming and sitting here. These organizations were outside, right? They were just accessing all of this over the internet. They were trying to create their infrastructure. Now, whatever they could create within their, data centers, they were allowed to create the same. They had the same freedom here in public cloud also, with much more features, many more features. All right. The benefits that cloud computing was giving, right? Those benefits were something that these organizations went behind, and that is why, you'll see a lot of, talk about modernization, migration. What is that? Nothing. Just organizations trying to pick up whatever they have in their on-premise environment and putting it on the cloud, right? Because the cloud will give you a lot of features and a lot of benefits, right? Many services on Azure are managed services, right? When we say managed services, it means that the backend part of that service will be managed by Azure, right? So you don't need a dedicated employee sitting there managing your resources for you. All right, you don't need that. So that is where the concept of public cloud now became popular. All right, so these were owned by the CSPs. One second, guys. Just a second. Yeah. So these were owned by the cloud service providers. Let me just change the color. Yeah. This was owned by CSPs, and they provided resources and services to multiple organizations and users, right? As an individual user also, you could go ahead and, uh, create resources on this data center, right? You and I can go ahead and create something over here. It's not just about organizations, right? I'll have my own tenant on Azure. I do have my own tenant on Azure. All right. You can also create your tenant on Azure, right? So everybody, including the organizations, can now go to the Azure cloud and create their own resources. It's available to all. That is why it's called as public cloud. All right. That is why it is called as a public cloud. All right. And you're going to access everything over the internet. That is something which is non-negotiable. Now, take the example of Infosys. We discussed, right? Infosys built private cloud first, right? Back in the day, they had their own data centers, and creation of this data center It required a lot of investment, right? So they cannot just throw it away, right? They cannot just throw their resources away, right? So they need to continue using their private cloud, but then for the increasing workload, they are now taking support from public cloud. All right. So organizations who already had private cloud in picture, but are now, extending their services on public cloud, what will you call such cloud where we have a combination of private and public both?
Hybrid.
What do we call it? Absolutely
Hybrid.
correct. We call it as the
Hybrid cloud.
hybrid cloud. All right. Now, one more thing is here. Let's talk about the cost, right? So when you talk about the cost with the various types of clouds, public, private, and hybrid, right? Hybrid means an organization which already had private cloud and is now using public cloud, right? So the cost is divided into three parts, right? One is called capex, other is called opex, and the third one is the rent, which is also a type of an opex only. Type of an opex, but I classify it as rent so that it's easier to understand, right? But rent is also an operational expenditure. We'll understand. Capex means initial investment, initial capital investment. All right. So when you build your house, there is an initial cost, the cost of buying all the bricks, buying all the steel, buying the cement, buying the wiring, buying the switches, right? Flooring, roofing, everything is the initial investment, the one time investment. All right. One time investment is called as a capital expenditure. Operational expenditure for my house. Can anybody tell me what will be the operational expenditure for my house? This is the recurring cost that you have to pay monthly. What is the monthly
Electricity
cost?
bill,
Electricity bill, house tax, right?
water. Yeah.
Recurring cost, water supply cost, right? Security cost, maintenance cost if it's there. So a lot of different costs are there which are recurring every month, but they are not huge, right? They're not huge. Huge cost would be building the house. That is the initial investment, the capital expenditure, the one time cost. And rent is when I am using a CSP based solution and I am renting the services on an hourly basis, something like this. So, three different types of costs are there. Now, my question to all of you is which cloud, and think very carefully, is the most expensive? And the second one is most secure. What do you think? Give me both of these answers. Which cloud do you think is the most expensive cloud? And which cloud do you think is the most secure cloud?
Might be GCP.
No. When I say cloud, right, I'm asking between the different cloud models that you've seen: public, private, and hybrid. Among these three,
Private is more secure. It is more
which
Public
one is most
will,
expensive?
yeah,
Public
public.
is the
private.
cheapest one.
Put your
Private
answers in the
is
chat window. I think
Private,
everybody
yeah.
is. Private is the
private.
most expensive.
Yes.
Yes,
All right. And most secure?
All
and
of
might be
them.
private. Private.
Private is considered to be most secure. Yes, that is true, right? Because it does not give you, but availability over the internet. Anything available on the internet is considered to be unsafe, right? That is why, as an administrator, when we create resources online, right? Let's say if you're creating a virtual machine, you generally do not keep a public IP address for that virtual machine, right? Keeping a public IP address means that it should not be publicly available. We use other methods to access the virtual machine. All right. We do not make it available directly on the internet. Clear? So public cloud, yes, it is considered to be most safe. Sorry, private cloud. That is why the banking organizations, right? Most of the banks, they rely on private cloud. Defense organizations, they also rely on private cloud generally. They will not put their data on public cloud. Clear? And the most expensive, you are saying private cloud, correct?
Yes.
Yes,
Let's see.
infrastructure, everything they have to take care.
Yes, understood. Let's see. All right. So costs, you have capex, opex, and the rent, correct? Now, when you talk about public cloud, private cloud, and hybrid cloud, right? Let me have it like this. The costs are capex, opex, and rent. In my public cloud, do I have any capex involved? Yes or no?
Yes.
Yes or no?
Yes.
No.
Yes. That initial investment
Capex.
is required, right?
What
Okay,
is
so
capex?
capex is the
Initial.
initial investment, the one-time cost of buying all the hardwares and let's say constructing the data center building and everything. The
No.
initial cost, that is a one-time cost.
Public
For public,
capex,
it is
no.
not required capex.
Yes, capex is not required. Why? Because I don't have to pay the capex. The
Yeah,
CSP will pay the capex, correct?
correct. And we're paying the
So
rent.
for
Okay.
me, from my perspective, am I putting in the capex in public cloud? No, I am not.
No.
Am I paying the OPEX? Am I paying the electricity bill and everything, the salaries and
No.
all? Operational expenditure involves paying the
Mm.
monthly recurring costs like salaries, electricity bills, internet bills, taxes, whatever it is. But
No.
I am not supposed to pay that. Am I going to pay the rent of the
Yes.
services that I'm
Yes.
using?
Yes.
Absolutely.
Yes.
I am responsible to pay the rent. Right? Whatever services I am using in public cloud, I have to pay the hourly rent. Whatever the duration of my usage is, I have to pay the accumulated cost for it. Correct? Perfect. Coming to private
You
cloud, when I
means
set up,
here organizations, right? I have one doubt.
yeah,
When
see,
when you
whoever
say
is using the
you,
public cloud, when I say you, I mean you as an individual also and you as an organization also. Anybody can create
okay.
an Azure account. All right.
Okay.
In
Yeah.
personal capacity also you can create an Azure account, a subscription you can get and start creating resources. As an organization also you can get a subscription and start creating resources. Whatever resources an organization can create, the same resources you can also create. All right.
Okay.
There is no filtering that is happening there. When it comes to private cloud, are we responsible to pay for the capex?
Yes.
And again, when I say we,
Yes.
it could be me if I am creating that private cloud. It could be the organization if organization has created that private cloud. So we do
Okay.
end up paying the capex. Why? Because this is my private cloud. I am going to build this from scratch. I'm going to build the building. I'm going to get all the hardwares, the servers, everything. I'm going to install the cooling system. I'm going to get the power backup. Everything is my responsibility in private cloud. Do I pay the operational expenditure?
Yes.
I do. Whoever the staff for my data center, the electricity cost, the internet cost, everything which is a recurring cost, I have to pay for it. Do I pay a rent here?
No.
No.
I don't pay a rent here. I don't pay any rent here. Coming to hybrid cloud, will I have capex?
Yes.
Yes.
Yes, because in hybrid I will also have my private cloud. So capex will be there.
Yes.
OPEX,
Yes. Yes.
OpEx will also be there. What about the rent?
Yes.
Yes.
The rent will also be there. So which cloud is most expensive now?
Hybrid.
Hybrid.
Hybrid. Hybrid cloud solution is the most expensive because you are using both, right? You are using private also and you are using public also. So when you are using both the offerings, then obviously you're going to pay more for it. Is this clear?
Y- y- Yes. Uh,
Yes.
I have one question actually on the public and the private part, right?
Yeah.
So if me as a person or a company, like if I get the service from the, let's say, Azure,
Hmm.
if I'm using their cloud service, right?
Hmm.
So will that be, though I'm using a public cloud,
Hmm.
will my cloud be private or will that be a public?
No, see, when you're using public cloud, your space is only your space.
It is
If you
still a
remember,
private only, right?
no, it's
Yeah, yeah.
see if it in definition, yes, it's private. It's your private property, right?
Okay.
But the resources will be created in the data center that has been created somewhere else
By
by the
somebody else.
cloud service provider. Yes. All right.
It
And you,
yeah.
hmm.
It will be secure only, right? It is not
Yes,
like a
yes,
public. It is not
very
like a
secure,
anybody
very
can view
secure.
it or something like
No,
that.
no, 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 no.
Yeah.
So that is where the directory and the tenant picture comes in. Your tenant will belong to you. Only the people you allow access to that tenant will have access to that tenant.
Got it.
Apart from that, nobody can see what is there. Even Azure cannot see what you're storing and where you're storing.
Okay.
If I got 1 terabyte of space from Azure, right, and I'm storing my data there, Azure can never see what data I'm storing. Never.
Got you.
All right. So the security is very high. You have a lot of security features, right? Microsoft Defender for Cloud, Sentinel. These are all different services that have been created to secure your environment. And that is something which cloud computing is offering, right? Security. They want to, assure everybody that they're highly
Hmm.
secure, right?
Got you.
Now,
Sorry to interrupt you. I have one doubt
mhm.
here. So nowadays, the hackers will hack that everything in the centers, right, to get the information. How these people are trust this cloud, even though if they provided the security.
I did not understand your question. Could you repeat? Wait, your voice
Actually,
is
hackers can hack that centers and get that data, right? So
hackers. Okay.
how
Yeah.
we can trust the data if, even though they provide the security? Just I'm asking a doubt.
See,
What
hackers.
type of?
That is what.
Yeah, yeah.
See, when you talk about hackers, right, we are going into a territory where it is all, a gray area, right? There has been no report of any hacker hacking into an Azure data center as of now, or any CSP data center. So that is the level of security that they have. If you've privately hosted something in your own data centers and they're able to get inside, that is different. All right.
Okay.
So whatever
Okay.
code you have running online, see, your application could be hacked. That could happen, right? But not the data center, right? But
Okay.
then again, who knows, right? The greatest of heists have happened. So, but I'll tell you, in general, cloud environment is very secure, highly secure. All right. They will continuously, check for any security vulnerability. They have a lot of resources running, which are, looking for any sort of attacks, any sort of, anomaly, right? Even when authenticating users. Now you will see uh, that back in the day, how did authentication happen on Facebook? If I ask you 10 years ago or 15 years ago, how would you authenticate onto your Facebook account or any other social media account?
Just
You
one
would
password.
enter just username and password was enough, right? That is it.
Yeah.
But you come to cloud computing today. You know what Azure is doing? They'll first ask for your username and password. Then they'll do MFA, right? Multi-factor authentication or two-factor authentication. Then they will ask for some other proof, right? After your username and password, they'll either take your biometrics or they'll, ask you to enter or open an authenticator app and then press a code or enter a code from the authenticator app, or they'll send you an SMS on your mobile phone that you have to enter. Even after 2FA has been done, Now they have conditional access in place,
Yeah.
right? So if any vulnerability is there, so in conditional access, what they say is that we are closely tracking the way you access your resources. If you access your resources every day sitting in Bangalore, and there is an attempt to log into your account from a location which is not natural, let's say somebody in US tries to log into your account, immediately the access will be blocked, right? Location flagged, right? Similarly, device flagging. If you're accessing from a compliant device, we'll give you access. If your device is not compliant, right, or connected to the organization's Entra ID, then we are not going to allow you to access the resources. So now they've added conditional access also. On top of conditional access, they have added role-based access control for security, right? So based on the role that you have, you'll only be able to access those resources, right? So now, if I look 15 years ago, I was able to access all my personal private information just by username and password, correct? And today now I have 4 or 5 different authentication and authorization methods also in place, right? So that is how the security has increased and it will continue to increase, right? There are a lot of things that they're doing regularly to increase the security.
So
So
I was
data
just,
centers.
yeah,
Mhm.
I was just curious then. So if the cloud, public cloud is so secure, why would people choose to have a private cloud?
Because they think private cloud is more
It's just
secure. Yes,
okay,
it's a psychology,
okay,
right? Sometimes that happens. This, it's more of a psychology that if we are not available on the internet, if we are secluded from everywhere else, we are more secure, right? But that might not be the case every time. Sometimes people will be scared to put their belongings in the bank locker. They would feel secure having it in their home, right?
yeah, correct, yeah,
That is a psychology. But
understood,
any day the bank locker is more secure than your house.
yeah,
So generally they, because what, banks are available to the public, right? It has public access. Your house does not have public access. So that is why they believe that it is more secure since public access is not there. But that is not how it works, right? So there's a
yeah,
psychology. That is why these defense organizations, you see in India, the banks and defense organizations, they rely on private cloud. You go to US is asking Azure, the US government is asking Azure to build their data centers for them. All
yeah,
right. So in US, we have these reserved data centers that are created by Azure, right? But used by only the US government, right? They will use those data centers for their compute purposes. So moving on, yeah, I think, guys, can you all please mute yourselves? Yeah, thank you. There's some disturbance coming in. So these are the different cloud models, all right, that we just saw. These are your various different cloud models, we call them, right? These are your models, the public, private, and hybrid. After models, we have something called as cloud services, all right? And before we go to cloud services, let's talk about the cloud benefits first. Now, high availability, all right? So these are the benefits that cloud gives you over your private data centers, all right? And I'll give you examples also here. When you talk about high availability, right? The first cloud benefit is high availability. And this means that your application or your resources are available. What does that mean? Has anybody ever tried to book a Tatkal ticket at 10 a.m. in the morning? Yes or no? You booked a Tatkal ticket?
Yes.
Yes.
Will you call that website highly available at 10 a.m.?
No.
No,
No.
it's not available. All right. It'll crash, it'll do all sorts of things, but you will never be able to reach the final page, right? It does not work. So that is called, low availability. Similarly, you go to State Bank of India, most of the time they will have just one response to all your queries. The bank servers are down. Now, servers being down, does that signify, high availability or low availability? That is low availability. So whenever I am unable to access my resources, it is called as low availability. And low availability creates a very bad customer experience. All right. It's a very bad customer experience. That is why Azure offers high availability. And how does Azure offers high availability? It offers high availability through SLA. What is SLA? SLA stands for Service Level Agreement. All right. And what is the Service Level Agreement? It's a guarantee. All right. Service Level Agreement is a guarantee, and Azure guarantees you that your application will be running. Right. So, how is this SLA provided? It is provided in percentage. So, for various services, Azure will have all different sorts of SLA. And let's say for a virtual machine's SLA could lie anywhere between 99.90 to 99.99. All right. So basically, there are three types of SLAs here. If it's a single machine, it's 99.90. If it's using an availability set, then it is 99.95. If it is using an availability zone, it is 99.99. So different architectures of creating the virtual machine, and with all different architectures, you get higher and higher availability. Now, what this 99.90 SLA or 99.95 SLA or 99.99 SLA means is that in 1 month, that is, we calculate by 30 days, in 30 days, the application would be up and running for at least 99.99% of the time. All right. So 99.99% of the time of 30 days, right, will result in 0.01% of outage. Yes or no? 0.01% of outage in total. And this is almost around 4 minutes. So I'm saying that in 30 days, the maximum duration for which your application might not be available is 4 minutes. So is that high availability or low availability?
Right.
That is high availability.
availability.
All right. If you calculate this, right, 30 into 24 into 60, you will get everything in minutes. Once you have everything in minutes, right, you can take out the 0.01% of it and you'll get to know. It's almost around 4 minutes. All right. So Azure offers high availability by various things. All right. It will create the architecture in a way that the application is always available. Whatever could go wrong is addressed. Right. For example, if my application is only there on one rack, it will increase the availability by hosting it on 2 racks. Right. If it is in 2 racks and this is a data center building, these racks are within the data center building. What if the building goes down? What it'll do? It'll replicate them in 2 data center buildings. So step by step, it can increase the availability as your requirements. All right. Then you have fault tolerance. What fault tolerance means is that you can deal with any sort of fault, right? For example, let us discuss about two types of faults. One is where you have a fault with electricity, right? And the other one is where you have fault with internet, right? So electrical fault, internet fault, how do I deal with that? How do you deal with electricity based fault or internet based fault? You have multiple power backups. Yes or no? Multiple. Why? Because if one of the main power fails, I have backup number one. If backup number one fails, I have backup number two, right? So I have multiple backups available. There could not be a situation where my data center will run out of electricity. It will never be. Similarly, if the fault is related to internet, what will I do? I will have connections from multiple ISPs, internet service providers. I'll not just have connectivity from one internet service provider. I'll use Geo also. I'll use ACT also. I'll use BSNL also. I'll use Airtel also. I'll use Vodafone India also. And trust me when I say, and I'm taking the names of these service providers. These are the actual service providers. All right. It's not that Vodafone and Geo are only into installing or giving you SIM cards. No, they provide high speed internet to these data centers. That is also a service that they are involved in. Clear? So to deal with any type of fault, we have a mechanism in place in cloud, and that is the benefit of cloud, right? So that was the second benefit. The third benefit is the benefit of scalability. Now, all of you know what scalability means? Yes or no?
Yes.
Increasing or
Yes.
decreasing.
Increase
Increasing
the
or decreasing. Now, if I ask
increase.
you, do you know if there are multiple types of scaling? How many types of scalings are there?
Yeah, horizontal
Horizontal
and
scaling
vertical.
and vertical scaling.
Absolutely correct. You have two different types of scaling. One is horizontal scaling and the other one is vertical scaling. And when we talk about Databricks, all right, when you talk about Databricks, this will come into the play. How? Traditionally, to process the data, I had something called as a monolithic system. What was a monolithic system? It was a single large machine with high compute, very high compute. Compute is what? Compute is CPU plus RAM, right? So very high CPU and RAM. And that single machine was very big. All right, don't think that I'm talking about a machine that is having 16 cores. No, not 16 cores. I'm talking about 200, 300 cores or 100 cores of CPU. All right, that is the size I'm talking about. And this monolithic system was used to process the data. All right. Now, what we did with this system was, as and when there was a requirement, we increased the capacity. If the RAM was, let's say, 500 GB, we made it 550 GB, right? So you increase the capacity of existing resources. What type of scaling is this? What type of scaling is this? This is your vertical scaling. By you had a machine, you increase the capacity and made that machine even bigger. So you are increasing it vertically. Clear? Yes or no?
Yes.
Coming to the distributed computing. Let me write it with a different color so you can understand there's a difference between the two. When it comes to distributed computing, on which your Hadoop also relied a bit. Um, Apache Spark relies on this, right? And Databricks relies on Apache Spark. So distributed computing. What did distributed computing say? It said that if required, I have one machine. If I need more power, I am not going to increase the capacity of this machine. I am going to add more machine. All right. If I need more machine, I'll keep on adding more machines. All right. So instead of increasing the size of a single large machine, I keep on adding more machines. What type of scalability is this? This is horizontal
Horizontal.
scaling.
Snowflake.
Yes. And this is what is used in Spark, Databricks, Hadoop. This is what is used. Horizontal scaling. These all individual machines are called as nodes and they are together called as a cluster or your compute cluster. So that is scalability. Clear? Now, after scalability, we had elasticity. Now, what elasticity says is, and it is very similar to scalability, elasticity and scalability go hand in hand. In both the places, we are talking about increasing the capacity of my resources. All right, in both of them. But with elasticity, it is a dynamic increase. The system's ability to increase the compute, increase the storage, or increase its resources dynamically. That is elasticity. All right, clear? When you can do it, auto scaling is dynamic. We call it an elastic system, right? Then you have global reach. What is global reach? Global reach is very simple. Global reach says that Azure is present everywhere in the world. Yes, and I'll show you the picture also, where you would be able to see that Azure is present in your. Or let me show it to you. Let me see if I have that picture available. Yeah. So, is it visible to all of you?
Yes.
We have a lot of data centers in North America. We have a few coming up in South America. We have a few in South Africa. We have a lot in Europe, then Middle East, India. In India, we have three data centers: West India, Central India, and South India. South India is present in Chennai. Central India is present in Pune, and West India is present in Mumbai. Then we have data centers here in Japan, China, Korea, right? Southeast Asia, and then Australia and New Zealand, right? So Azure is present around the globe, and that is what global reach means. But what is the need of global reach, right? Why do I need that? Why do I need global reach in Azure?
Mm,
Anyone?
Maybe you want to get it fast. You can.
Yes, latency. Latency is one of the reason. Yes.
Cost.
Yes. Cost. How cost?
Might be region to region. The charges will be different.
Yes, yes, that is different. See, I'm saying charges are different. Obviously, it's like petrol, right? You will buy petrol in some price over here in a particular state, and you go to the next state, and the price changes. So the cost is like that. All right. But what I want to understand is, see, pricing uh, is not going to affect global reach, right? Uh, that is on me to decide where I want to create it. Latency is one, right? If I want something near me, then I can have, right? Then I can make use of this feature where
To deal with the regional data,
could you repeat?
to deal with the regional data,
Regional
like
data. What is regional data?
in the sense, see, we have a one language and Spanish, they speak another. To process their particular own country's data, we will be
That could be done anywhere. It does not matter.
okay.
It does not matter. You were close, but not that.
Availability.
Availability, not really. It will be available, but latency is, yes, there. All right. Availability will be always there, but latency is something which, if I want to access the data fast, I'll have it in India rather than having it in US. Local regulations. For example, how many of you are using MasterCard? Anyone here who's using MasterCard or American Express?
Yes.
Yes. All right. So in 2000, tell you a short story and we'll end the session with that. In 2019, the government of India came out with a law, and this law required organization to store, data which was related to Indian citizens. All right, somewhere in India only. So in 2019, government of India came out with a law that required organizations to store data of Indian citizens somewhere in India. You understood this?
Got you.
And this is something that MasterCard and American Express and other companies also were not following at all, right? They were storing the data of Indian citizens in US. So the government asked them to stop their operations. And that is why, if I had, people I know working in American Express. I had people, in MasterCard also who were working in MasterCard. And I got to know from them that American Express and MasterCard have been banned, you know, from issuing any new cards. That is why for almost, I think, around October of 2022, starting from 2020, for 2 years, American Express did not issue a single new card in India for those 2 years. And you can search it online. It's available. Why? Because they were not compliant with local regulations. What was the local regulations? Local regulations required them to store data somewhere in India, right? So until and unless they built an infrastructure in India, right? Now they had two options: either to build their own infrastructure, or they can take help from Azure and create the infrastructure there, right? So this is where Azure came into the support or the help for all the other organizations that were storing data outside, and now it gave them a platform to store the data of Indian citizens in India. Clear? Have you heard of GDPR? Anyone who has heard of GDPR? It's a very famous regulation. It
Yeah.
stands for
Yes.
General Data Protection Regulation, and it applies to European Union. All right. The GDPR regulation says that information related to any European citizen cannot be stored anywhere outside Europe. All right. So, like this, there will be local regulations. And if there are local regulations, then you need to have the data centers present there to store the data. Is this clear now to everybody? Does this make sense?
Yes.
Yeah.
Yes.
All
So
right.
basically, all data centers will not have all the data. It's basically, every data center will have a different kind of a data, right?
Uh, I did not get it.
So, like for
What?
example, the
Hmm,
US,
yeah.
we have a data center.
Hmm.
Anything related to US will be stored in the US data center. Anything in the India,
If
it
the
will be
local
India,
regulation says so.
the
If
Europe.
the yeah, if the see American Express and Mastercard were keeping sensitive information, right?
Correct.
When you talk about transaction based, right, financial data of individuals from India, then they're that becomes sensitive data. So they're not stopped from keeping general data outside, but sensitive data that they cannot.
Yeah.
All right. Similarly, you would remember a lot of Chinese applications were banned at the same time, saying that they are storing our data, somewhere outside. We'll not allow that. Correct.
Yes.
So,
Yeah.
with that, we'll stop here for the day, and we again have a demo session tomorrow. Also, tomorrow we'll cover Spark architecture. All right. I'll take you through the journey of what Spark is all about, why it was created, how it is created, how it works, and what benefits it gives you over the traditional systems. And that is why, looking at those benefits, the Databricks rely on Spark as the core processing engine. All right. So we'll have a discussion on Spark tomorrow.
Yeah.
So I expect to see all
Yesterday,
of you tomorrow. Yeah.
sorry to interrupt. Yesterday
Yeah.
I
Go ahead.
didn't attend the session. Just I want to know what prerequisite we need to learn this Databricks.
See, you should know SQL and you should
Okay.
know basic Python.
Basic Python means scripting level is enough for
Yeah,
oops and
scripting level is
okay.
yes, scripting level is good level. I am talking about the basic level over here. One second. Yeah.
Okay.
Yeah. And you'll be able to understand everything that we do in the class if you have some basic understanding of Python. If you don't, we'll be sharing a basic level course with you that you can complete within a week. No problem.
And I'm like, so we will talk more about the cloud when we have the start the class, right?
For the first week, yes, we'll talk about Azure Cloud, but then we'll switch toward Databricks completely, and then we'll only relate to the services, that we'll be using from Azure.
Okay.
Yeah.
Shreyesh, I have one quick question.
Mhm.
Uh, Shreyesh, are you hearing me?
Yes, I can hear you.
Yeah, I was a part of projects where we're working in the EDW data warehousing side. I worked in Informatica Power Center tool for 5 years. So you know how that tool works, like getting the data from downstream and processing, transforming the data and loading into the tables
Yes.
into the tables, and where our upstream
Mhm.
will use the data for reporting side. I just
Mhm.
want to know overview of is this one even Azure also do the same the task the what is I was working in the ETL tool, the kind of
See,
taking the
ETL on any platform will always remain ETL, which will include three steps: extracting the data from the source, transforming the data, and then loading it to a warehouse.
yeah.
It'll always be that. Synapse lets you do ETL end to end. Data Factory lets you do ETL end to end. Databricks is also a service that lets you do ETL end to end.
Okay.
All right. So in Databricks
Okay.
also, we can get data from various sources. We can transform the data as we want.
Okay.
In place of data warehouse within Databricks, we have something called as a lake house. All right. So
Okay.
we follow a
Okay.
lake house architecture, not the data warehouse architecture. We can create data warehouse also. We can connect to, we can create a data warehouse in Synapse and then connect directly from my Databricks to Synapse. That also I can do. But when we talk about Databricks, we will study the lakehouse architecture, which is a mix of data lake and data warehouse, right? It takes the best of both worlds. So we'll see what that lakehouse architecture is and how you store data there.
Yeah, sure. Thank you.
All right. All right then. Thank you everyone. I'll see you guys again tomorrow, same time. Please do join the demo session. All right. Thank you all.
Thank you.